certified Linux administrator. Just passed the LPIC 201 Linux engineer certification. So the first thing when you boot into Parrot is you're going to get a kernel boot. We can show you on a VM what that looks like. So in a VM, this is what happens when you boot into Linux. You're going to get something that looks like that. If you add, where's the pointer? You can add kernel parameters to it, and there's a number of things you can add. I usually add the AppArmor kernel parameter. You can also do like no IPv6. You can do different hardware kernel parameters. So that's the first thing you're going to see when you boot into Parrot. So if you add SE Linux equals 1 and enforcing, that'll boot into SE Linux enforcing mode or AppArmor mode. Here are some references. There are hundreds of different kernel parameters that you can add during boot time. So if you want to download Parrot yourself, there's a different link. Download notes. So the first thing we're going to cover is checking the integrity of images. So images have something called SHA-1 or 256 or SHA 512 some hashes. So you can verify the integrity of that either towards those hashes or towards GPG keys. So this is how to do it. So right now I'm hashing out the SHA 256 sum of that ISO image. The developers create hashes of the different ISOs that they release. That way you can check that it came straight from the developer and it hasn't been messed with during transmission, or no one has injected malware into it. So as you see, those are lining up, which means that the integrity has been verified. So you can either do it with hash sums, or in the instance of things like Linux, they use GPG signatures. So you see here, this Tails GPG key, right? So GPG keys have fingerprints, and so when you check ISOs against the GPG signature, it ensures 100% that the integrity is good. So see, I'm listing signatures, and now I'm signing the key. So you have a public key, or you have a private key and a public key, and the developers are the same. So you check the person's public key against your private key, and that ensures the integrity. So right now I'm signing the L sign, which means local sign, the Tails GPG key. So it's now signed. And then I'm going to do a GPG-verify ISO. And that, like I said, that verifies the ISOs.asc, which is a signed ISO file against your GPG predicate. So like I said, that ensures the authenticity that it came straight from the developer. It wasn't man in the middle during the transaction. So that was got it. So we're going to start with, so that was, I covered J1, 286, 512, and GPG verification. The next thing is creating a GPG signature. So I have, let's see, you can export, you can create a GPG collection, which I've been doing over the years. I have on my GitLab, which you're going to find all my code on there, of everything I'm covering here. I have a collection of GPG signatures that I've collected over the years. So this is Seahorse, it's a GPG manager. So you see here, this is all the GPG keys that I've collected over the years. And you can export them and then import them later. I've also signed the collection file as well with my GPG signature. Let's see. So, cover creating a GPG key on command line. So there are 3 different ways in Parrot that you can create a GPG. You can use it on command line like this. You can use Seahorse, or you can use GPA. GPA and Seahorse are GUI interfaces. So this is on the CLI. So I like to do on the CLI. I like command line stuff a lot more than like GUI. Just GUI has a tendency to crash sometimes, and it never happens with the CLI. So right now I'm creating a RSA key. I'm creating 4096 bits, which is the highest bits for RSA. So I'm creating it, and it asks you how long you would like it to be active for. So I'm creating 6M, which is 6 months. So you can do 6 weeks. I usually just do 6 months. It's, usually, I like to install things pretty frequently, so 6 months. And then after that 6 months, it expires, and it's no good. So when people see your GPG key, they will see how long it's actually active for. After that active point, it expires. So, and then people know not to trust anything past that point. You can also create redact the key at you create a redaction point, and then you can state that. I also have on my GitLab page, I have quite a few different scripts. So if you go to gitlab.com/selfix, here's one of my repositories. And I just installed Parrot this morning, so this is exactly what the install looks like. I haven't modified it at all yet, so this is my GPG page. See that? GPG page, I have my public key. I created, this is kind of a testing document. So these are the hashes of this document. And then this document is also signed with my GPG key. That's what the .asc is for. And here are all the here are the commands, and here are the hashes. So on top of all of the hashes, it said there's the GPG signature of this document, stating that this document is verified. So you can sign that, you can verify that against my key. So two kind of cheat sheets that I created with different GPG related commands. And after this, I'm going to go on to metadata analysis. So that's my GPG signature, that's my email, and these are, what these do is they output the command gets sent to the GPG configuration. This is how you export your GPG key. This is how, that's how I exported it to that file. So if you look here, all these different files, this is the template, this is how I created those files. So you can replicate them yourself. So that, and then I said this as well. So when you grab GPG key, you get it from something called a key server. So you would add your GPG fingerprint to the end right here, and that's how you fetch it through that key server or that key server. You can also send keys to a key server. So that's pretty much everything you would need to know with the GPG. Like I said, that's on my GitLab page. So the next topic is metadata analysis. Also, I have all these, an example of all these different things on my YouTube page as well. It goes through how to do all this. Oh yeah, Firejail. Okay, so Firejail is, it's written in C, and it's a sandbox. It restricts things of many different natures. First thing, it restricts SecComp calls, which are system calls. It also restricts capabilities in Linux. Both of those restricting the bare bones aspect of infrastructure. It also restricts networking. There's also blacklisting. Can restrict the DNS resolver. So this is also going to go into hardening Firefox as well. Let's see. So first I'll do this one. So Firefox has a GUI. This is what the GUI looks like. So okay, so Firejail has a lot of different calls. Let me show you kind of what it looks like. So these are all the different calls that Firejail can execute. You can also do debugging and auditing of different programs. You can set things using their own private environment. You can restrict the etc directory, which is where it stores its configuration, or its bin directory, which stores its binaries, and make it so it can't interact with anything else in that environment. You can do trace logs. You can set it in a temp file system. You can restrict it from doing groups, so it can't pivot its way into other groups and get different permissions. You can also do like read-only directories, lots of different things. So, for an example, this is the Firejail configuration sheet. So, that up there is the DNS that Parrot uses. Parrot uses its own DNS, so it's not going to the Google servers or anything like that. So this is the Firejail wizard. So right now I'm opening up Firefox ESR. So as you can see here, I'm putting its own. I'm restricting it in the home directory in the downloads folder. That way it can't access anything else in the home folder. You can also restrict it to its own namespace, its own networking namespace. You can specify its own DNS resolver. You can limit the network protocol so it can't access like IPv6 or different packets and stuff like that. And it's on a nice GUI interface like this. So show you what's in this one here. Kind of explain it on the text pad what it's doing. So right now I'm setting the custom DNS resolver. Alright, so right here I'm enabling SecComp BPF, which is the Berkeley packet filter, which limits the system calls that it can access. I'm also disabling additional Linux capabilities. I'm also putting it in its own namespace. You can also restrict it from doing 3D acceleration, or accessing a CD drive, or disabling sound so we can't pivot into like the dev for instance of the sound. We can't access like things in the dev directory, different like hardware components. And then the last thing it's going to do, it's going to ask if you want to create a monitor. So Firejail has a monitor, and it'll show you the process. It'll show like the resource usage. That's it. It's very bottom. It'll show the resource usage. It'll show the system calls that it's accessing, the capabilities that it has enabled or disabled. It'll show its own folder, so you can also kind of merge it with different processes. So that's what it looks like here. It'll show the PID and stuff like that. So you can merge it with other processes, whether that be like a network process or whether that be like, for instance, for VMware, if you wanted to share directories with other virtual instances, it's kind of the same terminology here. So I started Firejail, SecComp, filtering, its own namespace, everything like that. So that's how you use Firejail to limit Firefox. So there's two GUIs. You can also create things like if you want to add the panel, you can add different processes. So you can create your own process and like pin it. So the next thing I'm going to cover is alright, so like I said, I just downloaded this today. So what I'm going to do is I'm going to do a live instance of setting a let me bring this up here first. So there's a open source project for restricting the about.config settings. Okay, someone's probably manually connected here. So, alright. So what I'm going to do is I'm deleting the Firefox because they have the Firefox Quantum installed. I use Firefox ESR because you can edit the configuration. It's much more privacy oriented. So there is a project called user.js, and it's on GitHub. And what you do is you clone the repository and you merge it into your Firefox configuration, and it limits a lot of the different capabilities. So I don't know if you guys have ever gone into the about config for Firefox, but you can modify very ingrained properties. So what you do, once this gets installed, I'll install that. Just while we're waiting for that.
I'm sorry, what version of Firefox did you say you used?
Firefox ESR. So it's spelled like this.
Oh, thanks.
Okay. Finish this up. Clone the repository. So I have this. It's in my GitLab page. This goes through all the different instructions for setting up the user.js project. Okay. You notice here, sandbox profile is updated. Firefox has Firejail ingrained into the core of it ever since the last major update, maybe 2 updates. See if I have Git installed. Okay, so cloning that repository. I assume because there's a conference, they probably have SSL script, or someone's stripping SSL.
They've stopped me on Wi-Fi in a few places I've tried to go to, so.
Yeah. I don't know. They had to have some sort of offense going over there, so someone's probably stripping SSL, I'm assuming. So that's probably not it. They can't clone or anything. Okay, so I guess I'll just move on to the next one. So I have 2 different. 2 different videos covering metadata analysis. So I just made this one recently, so I'll start off with this one. So, oh, I guess I have 3. So, alright. So, alright, this is injecting metadata. So what I'm doing in this video right now, I'm inspecting metadata of this image. So you will see that there's geographical location stuff. And this video is on my YouTube if you guys want to check it out. You can pull down the geographical location. You can make and model the camera, latitude, longitude, all that stuff. So right now I'm just inspecting the metadata of the image. As you can see, there's a degree where the camera was taken. And then what I'm going to do is I'm going to take another image which has, take one image that has metadata, and I'm going to implant it into another image. That way I'm actually replicating the things like the geographical location, the make the model, implanting it into another image, which you can see how it's definitely dangerous. It's this easy. Especially surveillance technology, you can just implant, oh, this person was at this place at this time. Oh, they're definitely guilty. So this is kind of just showing how the growing surveillance can be kind of an issue coming to the new. So that's inspecting it. And I also made a script that covered all this as well. It's on my GitLab page. So these are all the different commands that I covered. So these were inspecting it, exif code, exif tool is they use to actually implant the data. This is clearing all the data. So this is the image that I implanted the metadata into, and this was the image that I took the metadata from. So right here, I'm clearing all the metadata from this one. That way, there isn't any, it only shows one make and model, where it came from, the geographical location. So I clear all the metadata out of that one. And then right here, I put source as a variable. So whatever you want to put there. And then that's all the different exif data. So these are all different commands that you can use. Which one's implanting the exif data into the thumbnail. Tags, so it's going to take all the tags. So those are all the different commands that you can use for injecting metadata into other images. Let's see. And here's another one that I did of just plain extracting metadata from different images. So MAT is the Metadata Analysis Toolkit. It has a GUI, and it also has a CLI. You see here I did MAT display. You can see the GPS latitude, longitude. You can also see the GPS timestamp and stuff like that. So right now I'm just displaying the different attributes of the image. Now I'm using the exif tool and doing the same thing. See the date and time. You probably don't want to be pasting all this all over the internet, because if anyone's stalking you, it's pretty easy to find you. So That's covering finding all of the metadata. I'll also be covering removing the metadata. So you can either use MAT, the Metadata Analysis Toolkit, or you can use EXIF and then just basically wipe out all the different EXIF or XMP. There's probably like 7 different kinds of metadata that you can implant into images. Try to restart this here. So again, pulling more metadata out of the image. Probably 12 different tools you can use for extracting metadata. There was a recent botnet that was using metadata as a backbone for it, where when botnets have something called a command and control, which they have the victims connect back to instead of their box, so that they're able to stay anonymous. And what they did was what they used as a communication point, whereas the victim would connect back to PhotoBucket, and they would pull an image, and they would examine the image, and in the image metadata was a opcode, which they were able to translate into an IP address, which is very interesting. Very interesting idea. Let's see if. All right. It is. LibreOffice is responding. So.
10 minutes.
All right. Let me see. Last one. Cover one more thing here. Last one is creating a Lux encrypted USB drive. All the commands are on my GitLab page. So right now I have the USB is a live USB. So the last portion is going to be blank. This right here is blank. So right now I'm formatting it with the ext4. And then next I'm going to use a crypt mount to create a Lux encrypted partition. Here. Right now I'm making ext4 in the SDC3 partition, which is the last partition on the USB drive. I made a script for this, so it has all commands if you want to replicate this. Pull that out. Here, if you want to follow along, wrapping. All right, so this right here is creating the ext4 partition. Then we are creating the Lux formatted partition here. Then we are opening the Lux partition with that command. And then we're creating a persistent partition there. So you're able to, when you boot the USB, the live USB, you're able to mount the partition in the live instance as well. And it's, like I said, encrypted. So the next one is creating the label, which you're labeling it parent USB and making that a persistence instance. Here I'm creating a directory in the mount folder. Here I'm binding the dev mapper, which is a let's try this, a virtual hardware instance. I'm binding it with the mount directory and creating a union persistence instance right there. Next one is I'm checking status. See here, checking status and the Lux dump. It's kind of what he's doing, what I'm doing right there. Let me see here. So you're going to see there's slot 0 enabled, but there's the slot 1 is going to be the nuke slot. So slot 1 is the Lux encryption, and what I'm going to be doing next, right here, I added a nuke slot. So when you add a nuke slot, once you activate that nuke slot, there's no way to get that data back. It's gone. I mean, with like deleting files, you can find them, but actually deleting a nuke slot, there's no way of actually forensically carving that data. It's gone. So you see right here, I create a slot 1. You create a password. So if anyone were to forcibly make you unlock your persistence and you created a nuke slot and you entered that password, it would activate the kill switch and remove everything. So let's see. These are kind of just looking at the device, electrical volume information. There's the UUID, which is kind of hardware information that assigns a random device ID. So that's adding the nuke slot. That's dumping all the information. This is asking if it's a Lux device. Now here you can create a header backup. That way, if you ever to activate the nuke slot and then you wanted to go back and restore it later on, what you do is create the header backup. And then here's encrypting the header. That way no one can ever go behind your back and restore a backup. So that's OpenSSL, so it's encrypting of AES-256. This is kind of showing the file type. This is how to decrypt the header file. And here, this is I'm copying this file into the persistent partition. Now I'm unmounting and closing the Lux partition, and that's restoring the header. So, any questions? I covered a lot, so. There is a really good Telegram group, Parrot, the exact name. Leave laid off is kind of died on me, so I can't pull that off. So they have about 2,000 people. The group is really good. If you have any questions, they'll answer it. And the creator is in the group every day. So it's called Parrot Sec Group. If you want to go in there and if you have any questions. My GitLab page is gitlab.com/xe1phix.
There's two Parrot Sec. So there's one that says group and the other one's Parrot Sec.
Parrot Sec is the announcements. So Parrot Sec Group is the actual group. So there are, this really quick. There are tons of tools on Parrot. It's kind of like Kali, except for it's much smoother. It uses Mate. Kali uses GNOME and stuff like that, so it's much heavier. There are way more tools in Parrot. Their autocomplete is just insane. Like I said, Firejail -- it'll show all the different possibilities, and it's like that for every tool. So it saves a lot of time. It's just a cleaner environment. So I have a bunch of DVDs, so if anyone wants to take any home, go for it. Last version was 4.2, so no questions? All right.